Hi guys, Mrs. Senmol here. I'm going to go through today a video on midterm review number 3. This is going to help us review quadratic functions and graphs. So let's start with this one right here. What I'm looking at is a parabola, and the first question is asking me for the x-intercept. So I'm going to look to see where this graph crosses the x-axis, and I notice that there are two locations right here and right here. So I'm going to write them as coordinates. This is -2, 0. And the next one is 4, 0. X-intercepts are points where it crosses the x-axis. And notice that for the x-intercept, you have a number going in the spot of the x-coordinate. Remember, coordinates are written in the form x, comma, y. So now I'm going to go to the y-intercept. I want to figure out a point where it touches the y-axis. So I trace along. I notice here that this is the point in 0, comma, 8. Okay. The type of function equation, so what we're going to put there, this is coming from a quadratic function. Okay, that tells us when I'm looking at it, I can think of this as the y equals a x squared plus bx plus c. The type of graph that this is forming is a parabola, that U-shaped graph. The domain of every single parabola is going to be -infinity to infinity. Remember, not every function's domain is -infinity to infinity. When you see this quadratic function graphing a parabola where it continues on the left-hand side and it continues on the right-hand side, that's when we know -infinity to infinity. Now, when we go to the range, we're talking about the values of all the possible y coordinates. So we see that this function is pointing down to -infinity. And then the highest point it reaches is this tippy top right here, which has a y coordinate of 9. Your domain deals with the x values from left to right. Your range deals with the y values from bottom to top. Now we're going to look at the vertex of our function. The vertex of our function is that middle point. It's the extreme highest or the extreme lowest point of the graph. In this example, it's coordinate 1, 9. Notice how your axis of symmetry runs right through that. That's a dotted or dashed red line. So the axis of symmetry equation is going to be x equal to 1. Notice that if you have the vertex, you automatically have the axis of symmetry, and vice versa. If you're given the axis of symmetry, you have the start to your vertex. This parabola opens down. The vertex is the highest point, which is called a maximum. And when we go to the next question, they're asking about the transformations. Now, when we talk about transformations, we're moving from the origin to the vertex. That's with our shifting. So if I'm looking, I'm going to start right here at the vertex, and I want to go, at the origin, and I want to go up to the vertex. So in order to do that, I'm going to shift, translate, or move, right 1, and up 9. Now, since this parabola is opening downward, this is also a reflection over the x-axis. And again, when you're making, these graphs, or when you're seeing these graphs, you want to see the connection. So when it's opening down, it's going to be a reflection over the x-axis. It's a nice way to remember that transformation. That's one that you guys, I know, always kind of forget. So when we're looking here, we also want to consider the graphing pattern. But if I look at my vertex and then all the key points along the graph, I see that this is following a 1, 3, 5 graph pattern. Remember, 1A, 3A, 5A. So there's no stretch or compression on this graph. Now in this next example, this is not a quadratic function. This is a piecewise function because there's different pieces. You could see two lines on the left and right, and then you could see that quadratic in the middle, which is cool to see. But they want to know, is this a function? And this one is a function, yes, because it passes the vertical line test. When you are looking at this graph, or any graph, and you're trying to determine if it's a function, you want to take any vertical line, one line at a time, and you want to see, anytime you put that vertical line through, is it hitting in one and only one location? So right now you can see it's hitting the graph one time. If I move it over to here, it's still hitting one time. Over here, it's hitting one time. So we know that this is going to be a function because it passes the vertical line test. Move that over to the side. Now, when we're talking about the domain, again, this is going to talk about the x values, and we're moving left to right. When I'm looking at the domain, I want to look at the extreme left side, which is right here, and then I'm looking at the right side. Now, on the left side of the graph, we see it's starting at -5. It's an open circle signified by the parenthesis. On the right-hand side, you can see that it's an arrowhead showing that it's going to go on forever all the way to the right, which means it's going to go on to infinity. Now, even though it's pointing up, that's a good thing, but that's for range. So remember, the right side has an arrowhead, which means it continues along the x-axis, and that's where it's going to infinity. Now, when we look at the range, we want the bottom. And then we want the top of the graph, which again is going to be this point over here. So when I look at the bottommost point on the graph, this is -4. It's a solid line, so that's going to be a bracket. And then it's going all the way up and all the way up to infinity. Now my x-intercepts and my y-intercepts. So when I look at the x-intercepts, I want points along the x-axis. So I notice one x-intercept here. That's a coordinate -2, 0. And one right over here. That's a coordinate 2, 0. My y-intercept is going to be right across the y-axis. So that's the point here, 0, -4. Again, this is not a quadratic function because it has those two linear pieces on the end. Okay, these two sides right over here are showing that it's a line, not the quadratic U-shaped parabola. Okay, so now we're going to go into these examples. When we're looking at these, we know these are quadratic functions. We know that because the highest exponent here is a 2. All right, and what we are going to be doing is we're going to use for this one, since it's standard form, our A, B, and C values to figure out the axis of symmetry. So my A value is 2, my B value is -8, the C value, the constant, isn't there, so it's 0. I'm going to set up my formula, -b over 2a. This is a formula you need to know for the midterm. I would put it on your study card for sure, and then it will also be on your midterm exam itself, but you just want to make sure that you know how and when to utilize it. So I have the opposite of my b value. Notice the double negative, 1 from the formula, 1 from my b, over 2 times my a value. So I have 8 divided by 4, which is 2. The equation for the axis of symmetry, x equal 2. Now I remember from that first example that the axis of symmetry leads us into the portion of the vertex. So this 2 from the axis is leading us into the 2 from the vertex. And to find the y-coordinate, I'm going to plug that 2 into the function. So the function said 2x squared minus 8x. So now that we know that x is 2, I'm going to plug that in. So I get 2 squared, which is 4. 2 times 4 is 8. Minus 16 is going to be -8. That's the y value. Now I have to figure out my graph pattern. 1a, 3a, 5a. I can keep going 7a, 9a, but this is usually typically enough. So my a value is 2, so 1 times 2, 3 times 2, 5 times 2. So I have here 2, 6, 10. Notice for the graph pattern, I want the actual numbers for the graph pattern, not the formula. A lot of you were writing the 1a, 3a, 5a in. I want to make sure that we're actually putting the formula there. So now I'm going to graph to -8. And I'm going to go up 2 over 1, up 6 over 1, up 10 over 1. And then I repeat on the other side of my vertex. That parabola has that symmetry along the axis of symmetry, or kind of around that vertex. Now, we always say when we draw it in, it has to be a U. It can't be a V-shaped graph. So I'm trying to go from one side to the other. Erase if you need to. I usually draw it in 2 motions, okay, just so it's not too difficult for us. Now, this parabola is going to be opening up. The min or max value, remember this is a number, and this might be something you want to put on your study card, guys, that when they're asking for the min or max value, they're asking for a number, and then when they're asking for the min or max type, they're asking for a name, okay? So name it as a min or max, okay? Or sometimes they'll say vertex type there, and then we say min or max. All right, so min or max value, the lowest y value in this function is -8. That's going to come from the vertex there. Then we're going to look for the zeros of the function. So I'm going to trace along the x-axis. I'm noticing that we have 2 intercepts at 0, 0. And then we have another one at 4, 0 along the x-axis for your zeros, also known as x-intercepts. Now your y-intercept is also 0, 0, because it's hitting both the x and the y-axis at the origin. Domain of every parabola, -infinity to infinity. The range is going to be the bottom to the top, so this is -8 as my lowest value, all the way up to the top, which is infinity. Okay, and then we got to do our transformations to the parent function. Remember, I'm starting at the origin and then I'm moving towards my vertex. So in order to start at the origin and move to the vertex, I'm going to shift right 2. And down 8. Okay, but I'm also going to do something else here. I'm going to compare my 2, 6, 10 graphing pattern to my normal 1, 3, 5 graphing pattern. And I know that to get to these values, 1 became a 2, 3 became a 6, 5 became a 10, which means that we're stretching out those y coordinates. So this is a vertical stretch. Okay. Now in this next example, we're graphing another quadratic. We know that because if we look at the formula, we see that squared up top. But in this one, it's a little bit different because this is a vertex form. Notice the parentheses around that x plus 2. So this one, since it's vertex form, gives us the vertex very quickly. So what I'm going to do here is I take the opposite of the inside value. So I'm showing a positive 2. So the vertex says negative 2. And then the 8, okay, connected. And then x equals negative 2 for my axis of symmetry. Remember, don't forget that connection. That x equals negative 2 connecting to that negative 2 in the vertex. So now I'm going to go ahead and I'm going to do the graphing pattern. Again, just like that standard form equation, 1a, 3a, 5a. So my a value here is going to be that first number right in front of the parentheses. So 1 times negative 2, negative 2, 3 times negative 2, negative 6, 5 times negative 2, negative 10. Okay, the vertex type, this is asking for a max or a min, as opposed to the vertex value, which is asking for the min or max value, which is asking for a number. So here, all right, I could either think through this one. I see a negative graph pattern. I know it's going to open down, or I could wait till I graph. So let's go ahead and wait till we graph. Negative 2 over 8 up for my vertex. Down 2 over 1, down 6 over 1, down 10 over 1. I'm going to repeat on the other side of my vertex, and I'm going to graph in my function. The vertex type here is going to be a maximum. My min or max value, which is a number, is going to be 8. It's the y coordinate of the vertex. Remember, we talked about those connections, okay? A lot of different connections we see in the quadratic, a lot of pieces repeating. The x-intercept, when we look at the graph, I see 0, 0. I see negative 4, 0. Y-intercept, 0, 0. Again, it's places where it's touching the x-axis and then the y-axis, respectively. Domain of every single parabola is going to be negative infinity to infinity. The range of our function is going to be negative infinity up to 8. Lowest value, kind of showing if we're going to look visually, okay, the ends are pointing down, so negative infinity, then the topmost point of the graph, we're looking at 8, which makes our range negative infinity to 8. Transformations of the parent function. I want to move from the vertex, from the origin to the vertex. So in this one, I'm going to shift, translate, or move, whatever word you want, left 2, and up 8. This is opening down, so this is a reflection over the x-axis. And if I compare my graph pattern, I have a negative 2, negative 6, negative 10 to my normal 1, 3, 5. The comparison between the positive in the normal graph pattern and the negatives here points to my reflection, and then the 1 becoming a 2, the 3 becoming a 6, the 5 becoming a 10. Talk about a vertical stretch of this graph. When the absolute value of your a value is larger than 1, we're going to have a vertical stretch. When the absolute value of a is between 0 and 1, we're going to have a vertical compression. Again, the negative is going to control the reflection over the x-axis, so if we only have that positive, looking at that positive a value, that's a good thing to just kind of consider that positive a value when looking at the stretch or compression. That's why we say the absolute value. All right, moving on Now we're going to go back into our factoring. Okay, this is what we did a lot of this past month really in school. So let's go through one by one. This first example, number 5, we have 4 terms. This is a grouping problem. So we're going to group the first 2. I'm going to group the last 2. In that first set, 8y cubed minus 24y squared, I have a GCF of 8y squared. When I take that out of the first term, 8 divided by 8 is 1. I had 3 y's. I took out 2, so 1 is remaining. Then negative 24 divided by 8 is negative 3. I had 2 y's and I took both out, so none remaining there. Now when I look between y and negative 3, I notice that the only thing I have in common is a 1, which does not change the y minus 3 at all. That's a good thing because I want these binomials to match up, which they do in this case. You have to bring that out to the front. Last test, guys, I noticed a lot of you were not finalizing and finishing your factoring. You got to the second line, which is great, but you never got to the final answer. If you don't get down to this line right here, you're actually not doing the problem fully. Okay, all you're doing is setting up. You're never actually factoring, which is what we wanted to do here. So please make sure that you're getting down to that piece. I'm actually going to go down the odds, and then I'll go back and do the evens, just because these are all factoring, and then the other ones are all solving. So now again, I have 4 terms. I'm going to group first 2 together, last 2 together. In the first pair, they both have an x, leaving behind a y plus 3. The second group, 2y plus 6, they're both divisible by 2, so I'm going to factor 2 out, leaving behind y plus 3 again. These binomial factors are matching, so I'm going to pull that out to the front. And then I leave the x plus 2 behind. Okay. Now we're going down to the next one, question number 9. First step of factoring, don't forget, is always to identify if you have a GCF. So I'm going to take a 3 out, leave behind x squared minus 9. 3 and 27 were both divisible by 3, so I factored that out by division. And now I'm going to see what's my next step, looking at my x squared minus 9. I noticed I have 2 terms there. There's subtraction in between, and they're both perfect squares, so I know this is a difference of squares pattern. I like this pattern because once I identify it, it's pretty quick to do. 1 plus sign, 1 minus sign, doesn't matter the order. X times x makes x squared. 3 times 3 makes 9, and we are done. Okay, so again, difference of squares pattern coming after and only after the GCF. Couldn't do that in step 1 though, because 3 and 27 were not perfect squares. Alright, in this next example I have a trinomial. So in this one I'm going to set up my x method. I have a times c, so negative 40 up top, and then I have 3 at the bottom. So if I multiply 8 times negative 5, that gets me negative 40, and 8 minus 5 is 3. So I'm going to set up my grouping. This is how I choose to show you guys factoring, just because it's a process that works all the time. Guess and check is a great method, but sometimes for us, those multiplication and division facts don't go as quickly, and really addition and subtraction as we would like them to for that method, so that's why I think this is a little more beneficial, a little more plug and chug. So here, the GCF is going to be 4y, 20 divided by 4 leaves behind a 5 and a y, 8 divided by 4 leaves behind a 2. Now I go over negative 5y minus 2, I have a negative 1 in common, so I factor that out. Division, negative 5 divided by negative 1 is 5, negative 2 divided by negative 1 is 1. Oops, sorry, is 2. Quad that by looking at my binomials, okay, which is a good thing. So now I'm going to factor that piece out to the front, 5y plus 2, and then 4y minus 1. Okay, that is my final version there, my answer. Remember, when you're factoring and you see those pieces that are the same, those binomial factors, you're not done. You also have to pull that out to the front, okay? So that boxed answer is your final factored form. So now we're going to go through and we're going to do the counterparts. We're going to go through and solve by factoring. So in this example, number 6, we have 8m squared minus 4m. So we're going to factor out of 4m. 8 and 4 are both divisible by 4, and they both have one m in common. So now 8 divided by 4 is 2. I had 2 m's. I took 1 out. 1 is left behind, and negative 4 divided by 4 is negative 1. This is equal to 0, so now I'm going to set each piece equal to 0 using the zero product property. And I'm going to solve. So I divide this one by 4, And guys, you have the calculator, okay? I hate seeing mistakes here. 0 divided by 4 is 0. If you have 0 cookies to divide to your 4 friends, everybody gets nothing, 0. Okay? And then I'm going to add 1 to both sides. 2m equals 1. Divide each side by 2. And I get m equals 1/2. So my final answers here are m equals 0. Oops. And then m equals 1/2. You can write them separate, you can write them together however you want. Okay, just don't write them as a coordinate. Okay, these are two m values, not like an m and an n, like xy coordinate. Now in this next example, I have two terms. There is no GCF, but I have two terms, subtraction and perfect squares. So I know this is a difference of squares pattern. So when I do this one, I'm going to do 1 minus and 1 plus sign, doesn't matter the order. W times W makes W squared. 11 times 11 makes 121. And here I'm using the difference of squares pattern, so I don't want to use 1 and 21, because although they multiply to 121, they're not the square root of 121. So now I'm going to solve. W minus 11 equals 0. W plus 11 equals 0. So when I solve here, I add 11 to both sides. I get W equals 11. Here I subtract 11 from both sides. I see W equals negative 11. And again, circle up your final answer. This is a solving question, so I have to make sure that I'm getting down to those W equals, or the variable equals to a number piece, as opposed to something in like 7 where I'm stopping just when I'm in factored form. Okay. Now going on, I have two more. I have a trinomial that I'm going to factor. So I set it up. I do a times c up top. In this case, it's 1 times negative 20, which is negative 20. 1 at the bottom. And then I have 5, and I have negative 4. So I'm going to set up my factoring. I keep the first term, I keep the last term, but the middle pieces I'm going to split apart. So here I'm going to split it apart into 5n minus 4n. And then I set up my grouping. Remember, 5n minus 4n is positive 1n, and the reason why I picked those numbers, okay, why I picked the 5 and the negative 4 is because they multiplied to negative 20 and got us to 1. So those were my smart choices so that my grouping would work. Okay, now I'm just taking out GCF from both pieces. Negative 4 divided by negative 4 is 1, and negative 20 divided by negative 4 is positive 5. Make sure these are matching and don't force it, guys. What I've been seeing is a lot of forcing of those factors, which means that you're not actually getting to the right answer, but you're just trying to force it to work. All right, again, make sure, I'm going to put a little star here, make sure you get to this line to be showing you that fully factored form, so that way we can actually utilize the zero product property. So now I'm going to set n plus 5 equal to 0. I'm going to set n minus 4 equal to 0 and solve individually, so I get negative 5, and I get n equals 4. This was a solving question, so circling up those two final answers. Okay. And now on to the last one. I know you're probably sick of hearing me and sick of doing this review, okay, but remember, it's a really good review because this is going over all the skills we'll need for that midterm exam. So a times c up top, b at the bottom. I want to multiply to 28 and add to 11. So I think through my factor list. If you're not sure, go to the side. 1 times 28, 2 times 14. What else? 4 times 7, and oops, that's the one I want. 4 times 7 is 28, and 4 plus 7 is 11. So now I keep the first term. I keep the last term, but that middle piece, I'm going to go through and make into 4n plus 7n. Again, 4n plus 7n makes that 11n. I'm just breaking it apart into 4 terms so I can set up my grouping method. So now I'm going to take the 2n out, because that's my GCF. I leave behind n plus 2. Then I'm going to take a 7 out and leave behind an n plus 2 again. Oops, there's my plus sign. Equals 0. I know that I'm on the right track here. This is that n plus 2. I'm going to pull that out to the front. I actually think I forgot to highlight in the last example. So n plus 5 and n plus 5, just so we can see it. I like that kind of visual there. You guys know that I'm big on that. So n plus 2 coming out to the front, and then 2n plus 7 left behind equals 0. So now I'm going to set n plus 2 equal to 0, and 2n plus 7 equal to 0. So here I'm going to subtract 2 from both sides. I get n equals -2. Here I'm going to subtract 7 from both sides. So I get 2n equals -7. Divide each side by 2, guys. You want the variable alone, so that means you have to get rid of the 2, which gives us n equals -7/2, or you could write here -3.5. Either one is fine. I prefer the fraction, but it's okay either way. And circling up your final answer. Alright guys, hope that was helpful. We went through here graphing our quadratic functions, identifying and analyzing important pieces of quadratic and piecewise functions, and then solving by factoring. Midterm review number 4 is going to be very similar to midterm review number 3, same topic, same skills, just different problems to practice. And then again, midterm review number 5 is going to be a cumulative review of everything from marking period 1 and marking period 2. So good luck guys, you're going to do great.